Hey everyone, in this video I want to really explore what is the right load balancing solution or solutions to use for my solutions, maybe only in Azure, maybe in Azure and on premises as well. As always, if this is useful, a like, subscribe, comment and share is appreciated. Make sure you hit that bell to be notified when I post new videos. Now I could think about, I create some resource. Maybe it's a website, whatever that resource may be, and I could just have the one resource. But we have problems with that. We have problems around things like resiliency. Well, what if it's unavailable because of, hey, it's got planned maintenance and an upgrade of some sort of the app or the OS, or there's some unplanned problem, an app crash, an OS crash, a hardware failure. What if maybe I have users distributed geographically, so I want instances spread around? And so what we typically will see is we have multiple instances of some service. That gives us the ability to scale, even dynamically add and remove as we need based on the load. Gives us resiliency. If one fails, hey, there's others still available, and I could geographically distribute them. But as an end user, I don't want to have to know about, hey, there's a bunch of different endpoints. So we use some kind of central endpoint they can share, a load balancer. So here we can put in a solution, and that solution has an endpoint that the user can go and talk to, and it will then distribute to those backends, assuming they're available, which it can detect through some kind of health probing. Now, there are scenarios where maybe you don't use this kind of load balancer, and instead the user just gets told about all of the instances. Maybe it looks up a DNS entry and it gets lots of results, and it tries one, and then if it fails, it goes and tries another one. Your machine with Active Directory works like that. But for most things, we don't want that. We don't want the client to have to do the work. We want this kind of central endpoint. Now, when I think about putting in a load balancing solution, the first step is you have to understand your application. So maybe my application has multiple tiers. Hey, maybe there's kind of a database tier. And most likely if there's a database tier, there's kind of an active and a passive for most kind of relational databases. Then maybe there's some kind of middle tier element to it. And then maybe there's some kind of front end. So I have to understand these elements. Now, most databases, they have their own kind of maybe different listeners. They might have different addresses they use. So, hey, I'm going to go and talk to the active one automatically. Then the front ends need to know, okay, well, I'm going to go and talk to the middle tiers via this kind of load balancer. And then something has to come to the front ends and talk to those to balance them again. Now, is this private, within my network, or is this maybe public? It's coming from the internet. So I have to understand where that's coming from. And then I have to think about, well, where are these things? Are they, for example, all sitting in Azure? Great, they're all within kind of this maybe one region. Well, what happens then if you split them over multiple regions? Hey, I have all this same kind of stuff. Maybe I have kind of a passive copy over here, and I've got kind of this asynchronous replication going on. But absolutely, I have, again, a middle tier component. I have front end components. I have all of those same kind of solution parts. It gets a bit more complicated. Hey, I'll go and do my writes over here, but maybe I can read from there potentially. But now I have to think about, well, how do I balance between these things? So I have to understand all of these elements. Where's it coming from? Where are they? Are they kind of doing this geographical distribution to make sure I'm addressing the right need when I think about my solutions that I'm actually going to create? So I have to really understand my app and where I want my app and where the components are when I think about the right load balancing solution. Now, I drew a few different types of things. Hey, stuff coming maybe from the internet to front ends, maybe inter-tier type communications. And we have to really understand what is the type of that communication. Now, you'll often hear people talk about with load balancers, layer 4 and layer 7. That's based on the old OSI model where we had these 7 layers, but we really just care about 4 and 7. Because I can really think about it that layer 7, this is really the application. And what that means to us is, well, is it HTTP based? Now that could also be HTTP kind of S, it could be HTTP 2, the 2.0 kind of revision, the major new revision compared to the 1.1 we're used to. But are we dealing with HTTP, HTTPS, HTTP2 type traffic? If not, then there's kind of other tiers. There's kind of a presentation tier. There's a session tier. Again, I don't really care about any of these things. Then we get to layer 4. Now for layer 4, we're dealing with the transport. And the transport for what we care about is UDP or TCP. Now obviously there are others. There are other types of transport available. There's things like SCTP. That while they would work on an Azure Virtual Network, the load balancer solutions we're going to talk about do not support those things. So we're really talking about, is it UDP or TCP traffic? And then of course there's kind of layer 3. Layer 3 is just a network, i.e. for us, and then a virtual network is IP. And that can often be kind of V4 or V6. And then underneath that you get kind of data link and physical. Again, we don't see any of those things in Azure. What we see in Azure, a virtual network, is really that layer 3. We get an IP space. And on top of that IP, we can use TCP, UDP, various other things. So we need to understand fundamentally which of these are we focusing on. Is this HTTP type traffic, i.e. maybe I want to use a layer 7 solution. If it's not, it's just some other form of UDP, TCP, when I'm going to be using a layer 4 type solution. So that's what I really want to dive into. Now then we have to think, well, are they all within one region or are we distributing over multiple regions? And the way this works is there's a set of solutions we're going to use for within a region, i.e. intra-region. And then there are other solutions we can kind of lay on top if it's inter-region, i.e. I'm balancing between regions. So we're going to start off looking at things within a region. So we have Azure Load Balancer and the Azure App Gateway. Now I'm focusing on the Azure solutions. There were others. There were network virtual appliances that essentially are pre-configured virtual machines that perform these types of functionalities as well. Historically, they would still use an Azure load balancer in front of them to enable them to be resilient and maybe to scale. With the new Azure Route Server, maybe they don't have to use a load balancer anymore. They can use the equal cost multipathing ECMP and they can update the route table of the VNet and it doesn't have to have a load balancer in front of it anymore. However, for now, we're just going to focus on the Azure native solutions, but be aware there obviously are other solutions out there. So let's work our way up. Let's kind of start with the layer 4 solution. So my layer 4 solution is going to be the Azure Load Balancer. So I can think about, okay, great, I have this Azure Load Balancer thing. So this is my Azure Load Balancer. Now the Azure Load Balancer supports both TCP and UDP. So this thing is a layer 4 solution. That's kind of the key point. So it understands TCP and UDP. When we start talking about how it distributes traffic, it can understand the protocol. That's kind of a key point around it. Now it actually comes in 2 different SKUs. There's kind of a basic SKU, and then there is this kind of higher standard SKU. And we pay for the standard offering. Basic is free. Now, the basic supports, I think it's up to 300 instances on the back end. All of the VMs on the back end have to be in a single availability set or virtual machine scale set. So it's kind of limited in terms of what it has to support. The basic is open by default. There's no concept of outbound rules. It has no SLA. It's free. But the standard, this paid offering, well, it now supports the ability that this load balancer thing I create, it can either be zonal. I remember regions, when I think about an Azure region, well, an Azure region is actually made up, remember, of different physical facilities. And when those different physical facilities have independent cooling, power, communications, they're exposed as availability zones. So in my subscription for a region that supports AZs, I see AZ 1, 2, and 3. And so we can then use those. So a zonal deployment means zonal is deployed to a specific AZ that I specify. If it's zone redundant, well then it spans those zones automatically, so it's resilient against any individual zone having a problem. If I pick zonal, what I typically do is I deploy an instance to zone 1, 2, and 3, and then I use something else to kind of balance between them. So that's the whole idea of using zonal or zone redundant. Well, my standard SKU Azure Load Balancer can be zonal, or I can deploy it in that kind of zone redundant way. So now I have that better flexibility. And likewise, because that can be zone redundant, it can also use kind of a standard public IP, which also can be zone redundant. So I can hook on the front end there. If I think about, yes, I have a front end resource going into this, that front end can either be private, i.e. it's an internal IP address from the virtual network, or it can be public. And again, if I'm using the standard SKU, it can use a standard public IP, which then can also be zonal or zone redundant. So I can kind of match that. When I think about the back end of the kind of this standard load balancer, I have a lot more flexibility. So yes, I can put NICs. The standard way we do this is kind of a VM NIC is what I can have as kind of those back ends. It's the NICs we add to kind of a back end pool. Or the other nice thing we can do with standard is it can actually be IP addresses now as well. So I can just point to kind of particular IP addresses, which could be VMs, but they could also now be things like containers. A container doesn't have its own NIC, but it does have an IP address. So I can now have this IP range option for my load balancer. An important point is an Azure Load Balancer is one or the other. It's private or public. It cannot have both a private and a public. It's only one of them. So I have that choice to make, hey, what is talking to this thing? If I went back to my kind of architecture here, most likely front end's talking to middle tiers, that's internal. So I'd use an internal load balancer here. If maybe I was fronting some service to the internet, probably wants to be public facing. So I would pick that to match my requirements. So this is fantastic when I have that kind of layer 4, and I have a deep dive. If you go and look, I have an Azure Load Balancer deep dive that I go through all of this specific detail. But the key part is the traffic comes in, it goes through kind of a hashing algorithm, and that hashing algorithm is based on kind of the 5 tuples. You can think about, well, there's kind of the source IP, the destination IP, the protocol, because remember it's layer 4, it knows if it's TCP or UDP, the source port, and the destination port. So those 5 things by default, it's using in that 5 tuple distribution. So then if traffic's coming in from the same source, same port, same destination, same port, same protocol, it will always go to the same backend set member. Now sometimes maybe, hey, do you know what, the port's going to change? So there's also the option to do a 3 tuple where the ports can change, and I can also pick a 2 tuple where even the protocol could change. Now, as long as the source and destination is the same, it'll always go to the same backend set member. So I have those options. Now, a key point of this solution is these all have to be in the same VNet as the load balancer, which means it's in one location. Likewise, the load balancer itself is zonal or zone redundant, but it's contained within one particular region. It's using health probes to check they're available. It will only return healthy ones. But that's fundamentally what I'm getting there. One little point, when I put things behind a load balancer, it's going to use the load balancer for its outbound traffic as well. So there's a few little caveats you have to think about. If it's an internal standard load balancer, how's it going to get to the public internet? So there's things to consider there. But the Azure Load Balancer, fantastic. I can have VM NICs behind it. I can have IP ranges behind it. It can be zone redundant or zonal, private facing or public. It's one or the other. I can have multiple front end configurations. I can have multiple back end pools, but it's only of one type. Everything is either internal or it's all public. So that's great. That's kind of that layer 4. What about if when I'm looking at my workload, it's actually HTTP? And if it's HTTP, maybe I want some different stuff. This 5 tuple thing, I'm more interested in cookies and the session type affinity to go to the back end. Maybe I'm doing SSL and I want to kind of offload some of that work. Maybe I want to direct it based on the full path, which this has zero clue about because the path is sort of higher up in the stack, i.e. savviltech.net/something. I want to route based on that. Maybe I want to redirect from HTTP to HTTPS, use different listeners. So there's different things I might want to do if it's this HTTP type traffic. So I need a richer solution. So if I think richer solution, well, that's Azure App Gateway. So App Gateway, we'll draw that here. See if I can remember to draw the icon correctly. There we go. Right. If I do the App Gateway solution, so App Gateway is all about layer 7. It is all about HTTP, and again, HTTPS and HTTP2. It's kind of those things are all supported through that layer 7. So this now is my Azure App Gateway solution. So it's now focusing on that HTTP, HTTPS. Now there are basic SKUs, there are standard SKUs. Once again, there are different SKUs of this thing that affect both the pricing and actually the functionality as well. There's kind of actually this standard V2, which is what I'm going to focus on here. The other thing I can add to this is a web application firewall. Now, I guess I should have pointed out that standard V2 adds things like auto scale based on load. It also, so this standard offering here, now I can once again kind of do zonal deployments. I can do those zone redundant deployments. So it adds those kind of nice features. I'll do that in the same color, just so we remember, hey, these are kind of standard features. That's kind of giving me that capability. With that, because it's doing HTTP, I can also do things like SSL termination. As the request comes in, it can actually crack that open, look inside, and then forward it on. And it can encrypt it again, so I can have end-to-end encryption. But one of the nice things I can actually do with this solution, let's move that out of the way a little bit, is because I can do that SSL termination, I can actually add things like the web application firewall with this solution. So web application firewall is all about that open web application security project. There's a core rule set that helps me detect things like SQL injection attacks, cross-site scripting, and much more. There's different versions of these. But I get a much richer set of functionality, as I talked about, with all those different URL rewrites and path-based routing and redirects, all of these great things. Now, when I think about the front end of this is public, whether I use WAF or not, or public plus private. i.e. I cannot do a private only version of Azure App Gateway. It does not support that today. And once again, it has that kind of front end configuration. This is all going to seem very, very familiar. Once again, it's going to have kind of a back end pool, the things it can point to, and it can point to a lot. So I can point to things like virtual machines. I can point to things like a virtual machine scale set. I can point to things like app services. Now, I can even just point to IP addresses. I can just point to fully qualified domain names. So those things could actually be in other locations. They could be on premises. I could have sites like VPN or ExpressRoute, or they could just be a public endpoint. If this is a public IP, technically it could point to that thing. And again, it's using those kind of health probes. It actually even works with AKS pods because it has an ingress controller to help manage kind of those connections and the various routing. So I can have all of these different things that could then respond to that traffic. But the key point here is all of this is still within a region. This Azure App Gateway, even if it's zone redundant, is still contained in one region. The request comes in, it uses round robin to kind of distribute, and then it will send it to one of those. Those are really my options. So typically, within a region, I'm going to kind of look, and if it's a layer 7, especially if it's public facing, I'm probably going to use App Gateway. If it's not, then I'm probably going to use the Azure Load Balancer. Now, if it was internally and it was HTTPS, I still might use the load balancer here because maybe I don't care about path rewriting and path-based redirection and cracking open the SSL and doing all that stuff. I might not need that. I don't care about that. I just want this kind of to go through. So I have choices. But pretty much if this was public facing, I probably want things like the web application firewall. I probably want to use some of those redirection capabilities. This is probably the place I'm going to go. And of course, across both of these, if they're public endpoints, there's still things like the Azure Distributed Denial of Service Protection that we have, and then there's the standard version of that to help protect against DDoS type attacks. Also remember we have layers of the solution, remember? So different parts depending on the different layer I want. So that's great within a region, load balancer or app gateway. What about now if I have maybe stamps of that solution in different Azure regions? How do I do that? How do I kind of balance between those? And there's actually a bunch of different solutions. We can layer things on top. I'm actually going to stay up here at kind of the layer 7. So if it's the layer 7, I can think about, hey, I have multiple services that are available offering web-based stuff. So I'm staying up here. I'm still focusing on my kind of HTTP, again, S2, whatever that might be. I'm focusing again on my layer 7. So what we're going to do now is it's Azure Front Door. And once again, I have kind of a deep dive video on Azure Front Door, and it covers Traffic Manager as well in the same video. So go and check that out if you want the details. But Azure Front Door is a layer 7 global load balancing solution. If I think about Microsoft has this huge backbone network that kind of spans the world. And then connected to that global network, we have kind of lots of Azure regions. Now in those Azure regions, I might have instances of my service. Maybe I'm kind of got my kind of app gateways locally in the region. It could be a load balancer as well, but I have kind of instances of a service that are public facing. They have to be public facing. And then also off of this great big Microsoft network, there's a whole bunch of edge locations, points of presence. They're the same ones used by the Microsoft Content Delivery Network. And what Azure Front Door is, it creates an Anycast address for the service. And what the Anycast means is, so it's this Anycast IP, and that Anycast IP is essentially available at any of these points of presence. That same IP address is kind of made available through any of them. So now if I'm a user and I'm here, it also does something called split TCP. So the first thing is I'm going to go to whichever point location is closest to me. And what it does is it establishes kind of the TCP connection with me. Then it establishes the SSL, the TLS with me, all to that local point. So it's very fast. It's not having to go over here to do the TCP and the kind of TLS establishment. Then I send some request for some data. At this point, it goes to whichever one is closest and available, again, health probing. It gets a big chunk of data from whatever backend service. Remember, this is essentially redirecting to. And then it serves up that in small chunks over here as the response. So it's doing that split TCP, and it can cache it. It can add in things like web application firewall again on this solution. I can do SSL offload. I can do cookie-based affinity. There's URL redirect, URL rewrite. It's going to sound familiar. Layer 7, very similar to what App Gateway can do. And one of the cool things here is the backends. Yes, pretty much be anything in Azure, but it could actually also be, hey, I have maybe some on-premise thing that's got some public facing. That could actually be part of the Azure Front Door targets as well. I could actually target something that I'm hosting as well. Now, there are different versions of Azure Front Door. We're kind of now in this V2 world of Azure Front Door that has this standard and premium. It's really bringing together content delivery network for static content, Front Door for dynamic content, and then the premium adds things like the web application firewall. If we quickly looked at the comparison of the tiers, you can just kind of see over here, hey, it's telling you, hey, we're combining the CDN, the Front Door, and the WAF into this new standard and premium. And it really tells you the differences. So I can see things like, hey, the WAF is all of these things are really focused, or most there's a few yeses in there, but those for sure are part of the premium, and then kind of those security reports. So we have these different options. And again, I have that kind of deeper dive video around that. But really the key point for this is that Azure Front Door is designed around those, again, layer 7 HTTP workloads. That's all it works with, HTTP, HTTPS, HTTP2. And then it can, using that split TCP, that Anycast, it's going to optimize your performance, it's going to speed up, it's going to cache, add security, phenomenal solution. Okay, so what if it's not HTTP, HTTPS, it's something else? So then we come back into our kind of layer 4 world again. And if I was doing this previously a few months ago, I would have been talking about Azure Traffic Manager, which I'm going to talk about in a second. But we actually now have this new solution, the Azure Global Load Balancer. And I actually just released a video on this 2 days ago. So that's a deep dive. Go and check that out. But fundamentally, this is layer 4. So it's talking about that again, TCP and UDP. It doesn't care about anything above that. And the way this is really working is, again, you can think about that great big global network. And once again, we have these kind of regions hanging off of that global network. Now, what I have to have is within each region I want to use, remember, I have to have a standard load balancer that is public. That's the key point. The back end of the global load balancer are instances of the standard Azure load balancer with a public endpoint. So let's say I've got it in these 2 regions. I have standard load balancers. Each of them have their own public endpoint. Now, additionally, there are other regions, remember. So there's all these other regions as well scattered around. Now, I'm drawing this from a logical perspective. I can think about now, I can create this global standard load balancer that for the front end has a global standard public IP. Now these have to live in a specific home region, but if that region was unavailable, they still carry on working. And they're actually serviced by a whole bunch of other regions. But the back-end set of the global, you guessed it, are the regional standard load balancers. So when I use this thing, it's actually going to redirect to whichever one is closest to the user. So again, if I was over here, hey, I would kind of talk maybe there or whatever, I would go to this version of it. Now there are only certain regions participating. So if we look at the documentation here, it shows us, hey, ultra low latency. These are the regions we can actually create a global load balancer and a global public IP. If you try and create it in another region, it won't work. But again, if the home region goes down, don't worry, it's not going to affect it. And then we can actually see, hey, these are all the regions that participate in actually having, again, that Anycast. So that global public IP essentially becomes an Anycast IP. So this public IP, once again, this IP1, for example, or IP1 is available here, IP1 is available here, IP1, it's Anycasting that. It's available through all of those different regions to actually get to it. And one of the great things about this is this traffic coming in, it is pass-through. And why that's nice, what that really means is this has a client IP. That client IP will be seen by those back-end services. It's not getting abstracted away. This global public IP, you kind of own that. It's in your subscription, whereas with Front Door, it's just part of the service. You don't have absolute control over that. And I kind of have one of these. So if you look at my global load balancer deep dive, I go into detail, but hey, my load balancers, you can see I created regional ones. So this is just a regular regional load balancer. It has a public front end, and I had 2 VMs in it. And I created a global load balancer, and you can see the back end pull of this are my 2 regional standard load balancers. So now if I actually went to this in kind of any way, let's actually just copy that, that address over here. So if we go and look at it, so that's the public IP. If we just went to that IP address, oh, stop clicking it. If I just went to that now quickly, it goes to my standard load balancer in South Central because that's where I'm physically closest to. So that's really what that global load balancer is doing. It's just now available throughout all these different regions, but now, hey, fantastic. I can access it globally throughout the world, but again, it has to be public facing. Both Front Door and the Azure Global Load Balancer are public facing, not internal, and the resources have to be public facing. There is a third solution here, and this is currently in preview. I should be very careful about that. This is in preview right now. So the other solution is, well, it's Azure Traffic Manager. Now, Azure Traffic Manager is a DNS solution. Essentially, it adds a name, and then it will resolve that depending on whatever kind of routing criteria I give it. So once again, I could think about, hey, there's a whole bunch of different maybe Azure regions. But it could just as easily be, hey, I've got some on-premises thing over here. It really doesn't matter. But there's some kind of public IP, public name. So once again, it's public only. That's kind of the key thing with all of these. So there's public. And what I create in Azure is a traffic manager instance. So this is going to be some name.traffic manager.net, which I give it endpoints. So it points to that, it can point to that, it can point to that. Now, I never ever want to share that name with anything. So I would actually create an alias. So in my home DNS, like saviltech.net, I can create an alias, which is a CNAME record, that resolves to that name. So that's a CNAME, i.e. an alias. So what happens now is me as a user, let's say I'm sitting over here at my computer, and I want to go to www.saviltech.net. So I make a query to my DNS server. My DNS server then does a recursive lookup to find out, well, it will get that record and kind of send that response. Now, some of the challenges of this approach is the time to live. These records have a time to live. If that then went down, well, that record maybe lasted for a minute. So I will carry on talking to the dead one for a period of time. I have to wait for that TTL to expire before I'll actually go and look at a different one. And once again, we can kind of see this. So I did create a little traffic manager that points to the same backends. So this time, if I go home and I look at my traffic manager, you can see I created SavilTM. So its name is saviltm.trafficmanager.net. If I just go to that, there you go, I went to South Central. What I actually created was an alias record. So I can go www.tm.saviltech.net, which goes to, actually went to the other one. If we actually did an NS lookup, www.tm.saviltech.net, you'll see it's just an alias to, so there's my TM, which resolves to saviltm.trafficmanager.net, which actually resolved to the public name of one of them. So I can see those kind of three levels bouncing around. Just zoom in for a second. So you can see, hey, I've got my alias that I used, which actually resolves to my traffic manager name, which actually then Traffic Manager resolved it to my load balancer in one of my regions. So there are kind of different configurations you can do. In my case, I'm using performance, which is going to be based on the DNS latency of the lookup. Use the one closest to me, but there are weighted, priority, geographic, subnet based. And my endpoints are just those two public. But again, I could really add Azure endpoints, external endpoints, nested endpoints. I have a lot of flexibility in actually what I can do with that. So those are my really solutions there. Now, notice all of those global solutions are based on public. None of those would work for an internal balanced between different Azure regions. There are third-party NVAs that can do that kind of internal balancing, but today there is no native Azure solution. So you'd have to go and look at the NVAs to do that. But that's kind of the summary. So I think about within a region, hey, I can use the load balancer, the Azure load balancer, public or private. Or I could, if it was HTTP based, I could use Azure App Gateway, which adds a bunch of features because it understands HTTP, can do all those offloads and rewrites. Between regions, if it was HTTP, probably going to use Front Door. In preview, if it wasn't HTTP, I could maybe use the Azure Global Load Balancer or a DNS-based solution. That was a huge amount of stuff. The good news is there's actually something to help. If we go back over to the portal, if I go home, if I look up Load Balancer, you'll actually see there's this load balancing, help me choose. Well, that's very generous of it. So we can see that nice solution here. So if I select that, firstly, I can do a service comparison. Now, it does not show me Azure Global Load Balancer yet. Once it goes out of preview, that would then be included. But I can see, okay, so App Gateway, oh yeah, HTTP, HTTPS, HTTP2, same as Front Door. Okay, load balancer is TCP UDP. Does it support private load balancing? Okay, yeah, I can with load balancer and App Gateway. Or is it global? Okay, well, that's Front Door and Traffic Manager. How does it route? What are the supported environments? So load balancer is Azure only. App Gateway and Front Door and Traffic Manager, as I showed, kind of any of them. One of the nice things about App Gateway is it can do connection draining. Hey, I can actually say stop sending traffic to this box because then I want to do some maintenance around it. Talks about, hey, session affinity, all these different, I can just quickly see. I can see the security options, so WAF available for front door and app gateway. Network security groups for, well, just a regular load balancer. Traffic manager, none of them because it's the DNS solution. But even beyond that, there are tutorials to help me, but then it will help me choose. Hey, what am I trying to do? Does your application use HTTP, HTTPS? Well, yes, it does. So right now it's showing me 4 options. Yes, it's HTTP, HTTPS. Well, now it's going to restrict them down. We're going to throw Azure Load Balancer out the door. Okay, is it public facing? Yes. Is it deployed in multiple regions? Well, yes. Do you want performance acceleration? So remember, that's the thing that front door does because of that split TCP and the caching. Do you want SSL offload? And that's saying, okay, well, your solution should be front door and app gateway. I could go back and I could change some of my answers. If I say no, it's probably going to use traffic manager instead. Also, it's just saying, I was just saying front door on these. But basically, you go through and you answer the questions, and based on that, it will advise you on, hey, what is the best solution? So it's a great way to actually go and see it. And again, it links to all of the solutions within this one kind of area here on the left. So I can actually go and see all of my various things that I actually have in the environment. So it's really bringing it all together, making it simpler for me. So understand your application. Again, I would say if it was internal and maybe I'm trying to balance from the front end to this middle tier and maybe it was RESTful, you may not use App Gateway. You may still use something like an internal Azure Load Balancer there. But understand the options. And yeah, chances are, especially if you're multi-region, you're going to layer them. You're going to use one of these for within the region and then layer one of these on top of it for that sort of global balancing between them, assuming it's public facing. So that was it. I hope it was useful. Until next time, take care.